Hi guys, welcome to the channel Code by Raghav, and in this video we are going to learn the concept of the binary search. I'm hoping that you already know how the linear search works in the array. So if you don't know linear search, you have to understand it first, and you can see my playlist also, the linear search questions that are based on the linear search. So in this video we are going to see what is binary search and how to and we will see the algorithm binary search and how can we implement to search our target in an array. So what binary search is, let's take an example. If we take an dictionary and you have to search a word, like for example, let's say optimize, you have to search a word called optimize in a dictionary, in a physical dictionary. What you will not do, what you will not do, by going to A to Z, A to O, you will find this word optimize. You are flipping the page over page to just to find the word optimize. That you will not do, I'm hoping. So what you will do, what you will do mostly, you will probably find the middle of the dictionary and you will search. Let's say you hit the words that are starting from the letter M. So you know the optimize that starts with O will come after the letter M, means you have to search in the right half of the book. So this is the book and this is A to, let's say, O, not Z, and you have hit the middle M letter. Now you know I don't have to search the word optimize in the left half of this book. The word will be on the right side of the book, and what you will do, you will eliminate this search space. That I don't want to search optimize in this search space, so I don't need this search space. I will search the optimize in this half of the book. So that's the basically physical version, manual version of the binary search. Now let's go to your, in the computer science version, the IT version. Let's say you have an array and there is element, and there's one more important thing in the binary search space. Your, let's like your dictionary, these are sorted, that's why you hit the middle, and you know the O will appear after this letter M, means they are sorted. In binary search, array should be sorted. If it is not sorted, it can't be implemented. So let's say you have an sorted array 5, 7, 10, 15, 16. Now you want to see, now you want to search a element, let's say 10. Now what will you do? If you don't know binary search, what will you implement? You will start a loop from this. Let me write the indexing. If you don't know the binary search, what you will do, you will implement the linear search. You will start from this index 0 and you will run a loop till the n minus 1 index. So then you search and then you take every element and compare it is my target or not. It is not, then you go to next step and find your element until your elements hits. Now in binary search, what you will do, you will halve this array. Let's say this, what will be the half of this array? 5 by 2, that is 2. So this is your half. This is your midpoint. Now you will compare this midpoint, and you will you will compare with your target. Target is our 10. Is 7 is bigger than 10? No, it is not. Or you can write is like, is my target is bigger than 7? Yes, it is. Means my the target will be in the right side of the array, though it can't be on the left side of this. So you will eliminate this whole search space, and you will search only in this search space, only these three elements. You have the, let's say they are n element, you have the search space by n by 2, and you will run this step till the you will find your target 10, means single element. And now these are only 6 elements. Let's say you have 1 million elements in an array, and your target is at the 1 million, 1 million minus 1 index. So before the binary search, you will run the 1 million operations in linear search, 1 million operations to find this target. And in binary search, what you will do, you will halve the search space as you find your target, as you compare it is less than or greater than. So in the binary search, so linear search will take 1 million operation to find this search space. By using the binary search, it will take only 20 operations to find your element. As you can see, there are lot of, it makes your lot of computing easy. So that's why it is the very important and very helpful algorithm to search elements in an array. And let's see the power of, let's see the power of logarithmic logarithmic scaling. As you know, if there are n elements, so in linear search, what's the time complexity? It will be O of n. It's the linear time complexity. So in binary search, let's say there is n elements, and you are halving the search space as you find your target, as you go through your array and finding your target. Let's say you half more, n by 4, n by 8. You will find until there is only single element left. Single element left. That is your target. So let's say you run k steps, and to calculate the time complexity, total element is k, and you are halving the search space. And now 1. Now this will become 2 power of k equal to n, and the k will become log base 2n. So this is the time complexity to find the element in using the binary search. It's the mathematical complexity or time complexity, whatever you want to call. But in the computer science, in interviews or LeetCode or whatever you platform you are using, big O remove this base 2. ignores this base 2. So in interviews or in LeetCode or whatever platform you are using for this coding questions, the time complexity will be the O of log n, and the space complexity is O of 1. We are not using any search space to find the target. Let's see how this algorithm works and what we have to do. So in this algorithm we take 3 pointers, that is low and mid and high. So low will initialized at the index 0. This is the index 0, and the high is initialized on the n minus 1 index, means the last element. And we calculate the mid by using this low and high. For the simplicity, if there is no overflowing, to calculate the mid there is formula L plus R by 2 to calculate the mid. As you can see, there is 6 elements. There is 6 elements, and there's a mistake. So no, there's 5. Oh, I'm confusing. It will be 5. Our low is at 0 index and our high is at 5th index by 2. It will be become 2. So that's our mid. So there's no error. I was correct. Just I will get confused. But let's say your target, let's say if you have a huge data set and your target is at the int max, this is your target. If it is at the int max L index, so how will you find this? And your low is also at the index int max, and you will initialize your high as the int max, means the last element in the integer range. So how will you calculate the mid for this last element when we are at the end of this searching? So how will you calculate? If you implement this formula, low plus high by 2, this is high, you can say left plus right. So low is at int max and and this is also int max by 2. If you do 2 into int max, means 2 times of int max, means it is overflowing over the int overflow. In this is not like maths, 2 into int max upon 2, you will divide it. In the computer science, you have to perform your operations in sequence. So when you do this int max plus int max, it will become the 2 times of int max, and it will overflow the over the int range. So there are two solutions you can do. Either take long to prevent from this overflow condition, or you will use the formula that is made to solve this overflow problem, that is low plus high minus low by 2. So what it will do, let's say you are at int max, so int max, So int max minus int max, that will become 0. 0 divided by 2, that will become 0. You will get the last element. You will get the mid. So that's solve our overflow problem. And let's see how we perform the algorithm. So we have seen the 3 pointers where we have to place it and how to calculate the mid at every search space. Now let's see how we write this algorithm. First we have to write a termination condition in the while loop. So what will be a termination condition? It will be low is less than equal to high. Means if the high crosses low, means the element is does not exist. It doesn't. It's so it's the breaking point of our condition, and we will calculate the mid by the formula low plus high minus low by 2. After you will see now how we can move the indexes, move the pointers. If the array of mid is equal to the target, means we have found a target, it is on the middle, that it is on the mid index that we have calculated, and return the mid. Means if it is not there, it is not on the mid index, what you will write? Else if the array of mid is less than the target, means our target is bigger than array of mid, what we have to do? We have to remove the left search space. We have to eliminate this search space. We can't find the element in that search space. So what we will do, we will update the value of the low pointer to be mid plus 1. Now we are saying we are, after halving the search space, we are updating our low pointer, that we don't have to search in the left half. And else condition, the area of mid is smaller than, means area of mid is bigger than the target, means your target is smaller than the area of mid, means it is on the left half of your search space, means we have to eliminate this right half if mid is bigger than target. Here mid is less than the target. Now what we will do, we will, the high pointer that we have in the right half, means the that we have initialized at the n minus 1, we have to update it, and we have to say go to the left half of the search space. So high, what it will come? Mid minus 1. So that's how you can find the search space. So that's how you can find the an element inside an array using the binary search. Let's take a dry run and let's see. Let's say we have an element 1 2 4 10 16. Let's say 10 is our target, so target is our 10, this is 16. Let me write the indexing. So the low will be, so at the 0th index we will initialize it, and the high will be the n minus 1, 5 minus 1, that is 4th index. And we will run a loop while low is less than equal to high. Now we will calculate the mid. You can use, if you see the constraints and if you know it is in the range, it will not overflow, you can use the normal formula to calculate mid. So reading the constraint is very important step. So how, let's calculate the mid. L plus R, that means 0 plus 4 divided by 2, that is 2, means our mid is at this element. Now if, why I'm writing the code again, is mid equal to target? No, it is not. Now else if is mid less than the target, where is that mid? 4 is less than the target, that is 10. Yes, it is less than the target. That means here it is our mid currently. We L equal to mid plus 1. So we have to update this low. The low will come here. Now after this we will calculate the again. We will again calculate the mid. Now for this low, our low is at 3, our high is at 4 upon 2, that is 7 upon 2, that is 3. Now as you can see, we are getting the mid 3. Is mid equal to the target? Yes, our 10 is equal to the target. So return mid, return the index mid. Our target is at 3th index. Accepted in O of log n and O of 1 auxiliary search. So that's the video on the binary search. I hope you understand the concept of the binary search. It is simple, it is not that hard, but it is very important to, as the interview wise and in the search wise, it is far better than the linear search. There's only one condition: the array must be sorted. Don't forget this condition. Array must be sorted. You can't implement the binary search in the mixing elements, in the mix of elements. So that's it for the video. Thank you for watching. I hope you like this video. Thank you.